your job as a black belt. You've picked projects, right? You've helped kick off the continuous improvement program. You've selected projects. You're mentoring and coaching the belts as they go through their projects. I can't, you might be good at that, you might not. I can't really help you there. I can certainly talk about some experience that you can ask me questions during the course. But now you as a black belt also have to do projects. And the other thing about a black belt that's different than green belt is you need to know more of the statistical hypothesis testing. Now, there's two schools of thought. I believe the American Standard of Quality people of the world, or some of the consultants that bill by the day, are going to try to turn business people into statisticians. My goal is to turn business people into business people who know how to use statistics. So it's a huge difference. I'm going to help you know what hypothesis test to pick when faced with certain data types. But we have wonderful software out there today, such as the one you are going to do work in called Minitab, that does the analysis for you. It interprets the results for you. So you really need to know what is the appropriate test to pick. So what's the basis for hypothesis testing? Well, let's kind of go back through it. The basis for hypothesis testing is data type. Okay, you can only do certain types of hypothesis tests on certain types of data. For example, one that most people have heard of, the two-sample t-test. Well, that can only be done when you have a continuous Y, such as, let's say, sales by month. So Bob is selling something. All right, so this is Bob, and Sarah is selling something. And we want to know, does Sarah sell better than Bob? Well, sales in dollars is continuous, and Bob and Sarah are discrete. And I'll give you some tools. You can just say, oh, discrete, continuous Y, discrete X. It's a t-test. And then I have two X's. So it's a two-sample t. Now, I know this because I've been doing this enough, and I want you, you don't even have to remember it's a two-sample t-test right now. I want you to know where you can go find that answer. And then go, oh yeah, I remember doing that. So, data type drives it, okay? And we'll discuss that. But more importantly, we have our friend, the p-value, which we discussed when we were dealing with normality. In Greenbelt, the only hypothesis tests we did were, is data normal, and was there any special cause variation in the data? Okay, so let's talk p-value for a minute, because all of the hypothesis tests that we do, two-sample t-test, I showed you stepwise regression in an earlier module, they're all going to give us something called a p-value. So the p-value, I call it the layperson's guide to hypothesis testing. The p-value will tell you whether or not to accept or reject the, well, we got to draw, accept or reject the null hypothesis. Now this is also called H sub naught. Or should I accept the alternative hypothesis, which is called, you guessed it, H sub alpha. So I like to pretend that I've got a hurdle here, or a broad jumper. Someone's got to clear this wall. So here comes my broad jumper. My art is terrible. Pole vaulter, there you go. Sticks the pole in the ground, and where that person lands helps us accept or reject a hypothesis, okay? Now this is going to be your p-value at 0.05. So there's your p-value. So let's explain this, all right? So I said Bob and Sarah. It looked like Sarah sold a little bit more than Bob. Now, the first thing, you can sell more, but is it statistically significant? That's hypothesis testing. But the null hypothesis is equality. So you assume that Sarah does not outsell Bob until proven otherwise. That is your alternative. So the alternative hypothesis is not equal or greater than or less than. All right, if we are doing regression analysis, the null hypothesis, believe it or not, is not a predictor. You assume that sales is not a predictor of profitability, like we saw in my one example, until proven otherwise, okay? And then, of course, it is a predictor. If we have discrete data, if I have, let's say I run a hospital and women make up 51% of the US population and men make up 49%. If I have 100 nurses, I would expect 51 to be women and 49 to be men. But if you look at nursing today, you're most likely going to get 90 and 10. 90% of nurses today are women. It's a great career field. I come from a long line of nurses, by the way. My grandmother was a World War II nurse. My mother's a nurse. My aunt is a nurse. So needless to say, I could never go to the hospital. Does this proportion fit what I expect? And the answer, of course, would be no. Now, just because you have disproportion doesn't mean it's negative, but we have a disproportionate amount of women in nursing when compared to the population. So that is called, it fits what I expect. Or the other option in this case, it's independent. Nurse is independent of gender. All right, so those are just a couple of examples. And of course, then the alternative is it doesn't fit, and it's not independent. So for example, African American men unfortunately have a higher rate of prostate cancer diagnosis. That is based off of the chi-squared test of independence, okay? And you get a p-value less than 0.05. So we've got our hypothesis tests. By the way, this is a discrete Y, discrete X, greets, what did we say, sales and profit. That was a continuous Y, a continuous X, and then Bob and Sarah over sales. That was a continuous Y, discrete X. So all hypothesis testing is based on data type. We'll go back to that. I'll give you all the tools. I have a roadmap in Excel that I've developed for you. You can just go right to it and pick the hypothesis tests. But what I want to talk about here is how to interpret a hypothesis test. So the first thing I need to know is your confidence interval. How confident do you want to be that you're right? Or the inverse, 1 minus that, is your error. What is the probability that you're making an error? If I say that sales does not predict profit, am I making an error? If I'm saying sales does not predict profit, how confident do I want to be that I'm right? By default, Minitab, Excel, all the stat software out there generally has a confidence interval of 0.95. I want to be 95% confident that I'm right before I reject the null hypothesis, okay? Now 1 minus that, 0.05, well that's where your p-value comes from. I only want there to be a 5% likelihood that I'm making an error by saying that the alternative is true, okay? So I only, so here we go. We run the stats test, whatever stats test it is. So in this example, we're doing the 2-sample t-test and we're comparing Bob to Sarah and we get a p-value. Now we're going to plot it. Here's 0.05 to 0. All right, and then here is 100%. So this line is the error. So if you land over here, you're making an error by saying the null hypothesis isn't true. If you land over here, it's extremely low probability you're making an error. That's your p-value line. Now the inverse of that is I'm 0% confident when I reject this. I'm 95% confident when I reject this. I'm 100% confident. Okay, so here we go. I run the 2-sample t-test. I get a p-value of 0.45. We landed here. We did not get over the hurdle. We did not land in the alternative hypothesis area. We accept the null, even though visually, here was Bob. Remember our friend the box plot? And here was Sarah. Visually, yes, Sarah's selling more than Bob. It is not statistically significant. So the p-value did not get us over the wall. Now, if you remember regression, when I did does sales predict profit, the p-value was like 0.023, I believe. So we cleared the wall. Yes, sales was a predictor of profit. However, with regression, we also have to look at R squared, and it said yes, but one is not predicting the other, okay? If we do the nurse example, this is called chi-squared test. Goodness of fit. Does what I see in the hospital fit what I would expect? We'd probably get a p-value of, let's line through that, 0.001. We definitely cleared that wall. You are not making an error by saying that at that hospital there are a disproportionate amount of female nurses when compared to the population of women in America. Now that's why it's important you state your hypothesis clearly, because what if what you had said was, I have 85 women and 15 men, and I know that the population of nurses in America is 90-10. Does what I see fit what I expect? We'd probably get a p-value, I don't know, of 0.32. We did not get over the wall. You accept that your population fits the expected population. So the p-value is the lay person's guide to statistics, and let's simplify it again. If the p-value is less than 0.05, now you can change that. You can be 90% confident, so then it needs to be less than 0.10. You might want to be 99% confident, like in some pharmaceutical drug testing, because the side effects are so severe, the FDA says you have to be 99% confident the drug works. In fact, let's do that real quick, because I think that'll be helpful. I know this is a bit, I don't want to lose my, all right, I don't want to lose that. So I have the placebo. Let's say the drug is going to reduce white blood cells. So this is a cancer attacking drug. And I have the placebo and I have the drug, right? And I have the white blood cell count. You'll have to excuse me if I am using the wrong levels. I don't know what it's supposed to be. And then I've got the drug. All right, so I've got placebo versus drug. The drug is supposed to lower the white blood cell count. Clearly it is not. Continuous Y, discrete X, two sample T. And we get a p-value of, let's say, 0.54. Unfortunately, we cannot take our drug to market. It did not work. It did not lower white blood cell count. All right, so that's hypothesis testing. It's going to be super easy. Minitab is going to walk you through it. Minitab is actually going to give you the answer. It's a very affordable piece of software while you have a .edu email extension. And your job really as a black belt in my course is to know what type of data do you have, continuous Y, discrete Y, what type of X you have, where to find the appropriate hypothesis test, and mostly important, an understanding of the p-value.